In the preceding video, we learned about independent variables and dependent variables. In this video, we'll use that information to start talking about regression models, which allow us to have one or more independent variables as features in a model, and we try to use those to predict some outcome that depends on those features. The first type of regression model that we're talking about is a linear regression model, which allows us to predict some continuous outcome, some continuous dependent variable. An example of such a continuous variable is house price. So if we'd like to predict the price of a house, we could use a regression model to try to do that. So regression models always have something called a y-intercept. So we have some parameter here that we learn with our model that allows us to have an average house price. If we didn't have this y-intercept, then we would be stuck with our regression model assuming by default that a house price should be $0 on average. And I can't imagine that's what we'd want. We rarely want a model that by default predicts an outcome of 0. So you're pretty much always going to want to have this y-intercept in your model. All of the other parameters in your model, like b, c, and all the way through to m here, these are parameters that learn the relative influence of other features, of independent variables in your model. So the house price here is the outcome that we're predicting. It's the dependent variable. And all of the other data points that we have on our houses, we're going to use those as features to predict the price. So one of our features could be distance to school. How many kilometers is this house from a school? Another predictor could be how many bedrooms are there in the house? We could have many predictors. It isn't uncommon to have half a dozen or a dozen predictors in a regression model. And so I have all the way through to m predictors here. And then these parameters b, c, and m, they based on these particular data points, x1, x2, all the way through to xm, will reflect the relative influence of these features, x1, x2, all the way through to xm, on the house price. And so all together, our y-intercept plus all of these other terms could become a good model for predicting the house prices that we have in our data set. Okay, so this provides you with the general idea of what we're doing. Let's go into a bit more detail by talking about individual rows of data. So if this is our general model for predicting house prices, then we have this vector, this column of house prices through to n house prices. So the number of rows in this diagram corresponds to the number of data points that we have, the number of house prices that we have. So we have our first house price, our second house price, all the way through to our nth house price. And we're predicting these house prices, these y values, with these x values. So this one here, x11, this is the first feature of the first house. So this could be the distance to school for the first house. It could be 3 kilometers. And then this one here is the corresponding feature for the second house. So it could be 5 kilometers from a school, say. And then here, x12 corresponds to the number of bedrooms in the first house. So let's say it's 3 bedrooms. And this one corresponds to the number of bedrooms in the second house. So it could be 4 bedrooms or what have you. And this trend continues all the way through to our mth feature for our first house, as well as the mth feature for our second house, all the way through to the mth feature for our nth house. So for any house I in the data set, yi is the price for that house, and xi1 through to xim are the features for predicting that particular house. Our goal with our regression model is to solve for these parameters, a, b, c, all the way through to m. which will weight the relative influence of these features for predicting our house price. We can mathematically simplify what I'm showing here by using linear algebra. So this is a topic that we cover in detail in my linear algebra for machine learning live lessons, which are available elsewhere, but quickly we can use matrix multiplication to put all of our inputs, all of our x values that we're using to predict our house price into a matrix, as well as a column of ones in the left-hand column of the matrix. So this is just for that y-intercept that allows us to have the average house price accounted for by our model. And then we multiply this matrix of features by a vector of model parameters. So our A corresponds to that y-intercept, that column of ones, and then the parameters B, C, all the way through to M correspond to the columns of this feature matrix. So this feature matrix will be M features wide. Well, it'll really be M plus 1 features wide because we also have this extra column, but that's a little bit of detail that we don't need to worry about just for explaining this at a high level. So it's M features wide and N cases tall. And so we can mathematically, using linear algebra, we can predict the values in our vector of house prices, so each of the individual house prices, by multiplying our matrix of features by our vector of model parameters. Okay, so there's your high-level overview of what we're trying to accomplish with a regression model. We have our outcomes that we're predicting, and we're predicting them with our matrix of features multiplied by our vector of learned model parameters. Up next, we'll jump into hands-on code demos to get a real working understanding of this with real numbers.